I'm planning on this video being pretty short. I wanted to touch on one other type of selection structure. Previously, we've talked about if statements, else if, and else statements. And those are things that we can check a condition with, and we can select to run something, to not run something, to skip over something. This is going to be very, very similar. In this case, I have a variable called x, and right now it has a 0 in it. Previously, we'd do something like this. If x equaled 0, we'd put something in here and we'd have it run. Else if x equaled 1, we could have something else happen. And then lastly, we could have an else. And so we do something along these lines. What I want to do is I want to show you something a little bit different. What we're going to do is we're going to use a switch case. I'm simply going to type the word switch, and in parentheses, I'm going to put my variable x. And that's it. There's no condition in here. I'm just letting it know what variable I want it to check. I'm going to go ahead and open a scope. And what I'm going to do down here is I'm going to write the word case. After I write the word case, what I'm going to do is I'm going to put the case that I want it to check, or in other words, I want it to check the value of x. So in the case that x equals something, I want it to run this chunk of code. In this case, I'm going to put a 0. So in the case that x is 0, I'm going to go ahead and do something. My syntax here is case with a space. I put an integer here, and then I put a colon. The other thing that's allowed here besides integers is characters as well, but it either has to be a character or an integer. Now, underneath this case, I can put as many lines of code as I want. This is where I could blink an LED. I could do something else with LEDs. I could play sounds. I could turn on servos or motors. I could call functions. I could do whatever I want. I can have as many lines of code in this case as I want. Just for this video, I'm going to keep this pretty simple. Serial.print, and I'm just going to print case 1. Now that's not everything. When you're done, in this case I have 1 line of code, you're not just done when you type out your last line of code. You have to do one more thing, and what that is you have to write the word break. What that's going to do is it's going to tell it that it can leave this switch statement. It's going to be able to leave and go elsewhere in the code. It'll just continue the code like it normally would. Let's say that I want another case. What if I want a case where x equals 1? Well, I could go ahead and do that. I went ahead and I noticed that I meant to put a 0 up here in the first one. So this first one's going to print case 0 when case 0 is run. And case 1 is going to print case 1. Again, I'm going to go ahead and put my break in. And so this first one's like an if statement. The rest of these could be thought of kind of like as an else if. It still has a condition. It has a value that it's looking for. But what about an else? What if there's some other case I'm not thinking of? There's a default. And that's all you'd write. You'd say default, and then you could do whatever you want in your default. In this case, I'm just going to write default. And again, I'm not going to forget to write break. And that's it. So right now, what should be printing is 0, case 0, because case 0 is true. In other words, it's checking x and it's saying what is the case of x? What is it holding? And in this case, it's holding a 0. This one's pretty boring because I can't change x while this is running. I could stop this and I could say, all right, well, what if we put a 1 in here Well, in this case, x equals 1, so it's going to run case 1. And what if I were to put a 2 in here? Well, in this case, I have a case 0, I have a case 1, then I have a default. If it's not 0, if it's not 1, do the default code. You could do this with buttons. You could do it with a lot of different inputs. It's done often when people are going to put commands in with their keyboard or with a keypad. I do want to just show one quick thing that you could do. I have a potentiometer set up over here. And what I'm going to do is I'm very quickly going to make a variable that holds my potentiometer value. And I believe it is plugged into pin 0. Now, a problem with this one is this potentiometer, it's plugged into my analog read, which means I have 1,024 cases. And I don't want to type out that many cases. There is that default, so it's not the fact that I have to write out 1,024. I could have some be defaults, but to be honest, I don't even want to come anywhere close to writing 1,000 different cases, especially for a simple video just trying to show what a switch case is. I only want to write maybe 2 or 3 cases. There is a function that I want to tell you guys about. It's called the mapping function. And what it's going to do is when I have a value, I have one saved right here, it's in between 0 and 1023. I'm going to go ahead, I'll make a new variable. You don't always have to make a new variable. I'm just going to call this map val. What you do is you write the word map, and this is a function. And we've done lots of functions. Analog read is a function, it has 1 input. Map is a function, it has 5 inputs, and you got to put them in the right order. So I'm going to tell you what this right order is. The first input is the value that you want to map, or the value that you want to adjust. And that's going to be my variable, the thing that can change, the thing that I've measured. So I'm going to go ahead and I'm going to put val in right here. So that's the thing that I want to change. The next 2 things that I'm going to put in here are going to be this original number. So val, what is its minimum value that it could be, and what is its maximum value that it could be? Well, this was measured, and it could be as small as 0, and it could be as large as 1023. And so that's what I do. I put in what is my measured value, that variable it's holding it, what's the minimum that that number could be, what's the maximum that number could be. And then my last 2 are, I'm going to adjust that number to fit on a new scale. Instead of a scale going from 0 to 1023, I could have this go from 0 to 1,000, or from 0 to 100, or from 0 to 10, or from 0 to 3. And that's it. What it's going to do is it's going to take this reading and it's just going to readjust the scale. So now when I turn my potentiometer, I'm not getting a well, I am getting a 0 all the way up to a 1023, but I'm going to readjust that into a new variable where I can only get 0 at its minimum and 3 at its maximum. I'm going to go ahead and I'm going to use this mapped value as my case. So we have it turned all the way down here, which means it's case 0. If I turn this up just slightly, it's still case 0. And as I approach about 1/3 of the way up, it changes to case 1. And it's still going to stay case 1 until I get about 2/3 of the way up. And then it jumps into my default. What's happening here is I have turned my potentiometer, instead of having that range of 0 to 1023, my potentiometer now has a range from 0 to 3. And if we wanted to, I could go ahead, just so that we could see what's happening maybe a little bit more. I'm going to go ahead and comment out my serial prints inside of my cases for now. And I'm going to make some prints outside of here so that we can see what's happening with this map function a little bit more. Or serial print ln, and this is going to be val. We're going to see how our analog number is coming. This is the value that's going to be between 0 and 1023. And serial print ln my map val. This is going to be kind of a mess. I'm going to go ahead, I'll put a delay in. We'll do a 2-second delay. And I might clean it up here in just a second. So I'm turned all the way up. So I'm at 1023, and that gives me a value of 3. I'm going to turn it slightly down, and I'm at 982. And it maps it to my number 2. I turn it into the middle somewhere. I'm now at 593. That's the actual number that's being read by my analog read, but I'm mapping it now so that that value is 1. And when I turn this down a little bit more, I'm now at 184, and it maps down to 0. So I think that worked okay. So what is happening is I'm going to go ahead and I'm going to take these prints out here. I'm going to go back to the prints that I have inside my switch statements. And remember, it was 0. That was the value that was coming out of my mapped value, which means that map value equaled 0. So it came into case 0, and it's going to run these lines of code. However many lines of code I have, it will run. It'll hit this break, and then it will be kicked all the way out of my switch. It'll continue on with anything that I have below that switch statement. Because I'm in a loop, it'll come back up to the top. It'll take a new reading. It'll remap it. It will delay, and then it will find the case that it needs to jump into. In this case, it's still case 0 because I haven't changed my potentiometer. If I turn this a little bit, we are now at case 1. And the reason for that is because it took a new reading, it remapped that value, and it remapped it to equal 1. And so now it jumped into case 1. It runs as many lines as I have in case 1. In this case, it prints the word case 1. We go to break. So it breaks out of this scope, comes down to the end, and it's going to do the whole thing over again. And when I turn this up a little higher, it's now at default. It's at a default because it's not being mapped. My value isn't being mapped to 0. It's not being mapped to 1. It's being mapped to 2. And I don't have a case for 2. So what it does the default. It runs as many lines of code as I have. It reads the break, and it leaves the switch statement. And that is the switch case.